CAMS is the Center for Accelerator Mass Spectrometry. Our goal is first and foremost AMS, which is high precision isotope ratios, but we take advantage of a nuclear particle accelerator to do that. When doing a nuclear experiment here at the lab, CAMS is one of the unique facilities that has an accelerator, and building an experiment to study any type of nuclear reaction, you need some type of high energy source, and accelerating particles to a high energy takes advantage of the accelerator that we have here in this facility.
Multidisciplinary Training Experience in Nuclear Science, or Mt.ENS program, is a training and research internship that is based in both San Jose State and Livermore National Labs, in which our students get to take a class in the spring semester where they learn a little bit of introductory nuclear science, and get introduced into the type of projects that they'll be doing over the summer, as well as slowly get onboarded into the Livermore system, where we come and do 5 tours during the spring semester, and then they start their full 10-week internship at 40 hours a week in the summer.
This program is a true partnership between San Jose State and Livermore. Dr. Esper did a lot of legwork in giving them a theoretical and topical discussion and background for nuclear science.
The idea of this program is to partner with a minority serving institution like San Jose State University and bring undergraduate students from different fields early in their career path to introduce them to nuclear science. This we try to do through a common project that they will be all working on different tasks of the same project. Each will be focusing on one component, but also interact with each other, so that there is an understanding that, nuclear science is something that we do as part of a group, and it's not something that you can do on your own.
I've primarily been focusing here on target prep. I've also been doing some separation techniques, which are both important for nuclear reactions, like we're doing here at CAMS. I'd argue that target prep is one of the most important things, or important parts of a reaction happening here at CAMS, because the targets really do have to be perfect for a reaction to go the way you want it to go. So making sure that everything goes to plan with the target is definitely an important first step to make sure the things you want to happen actually do happen.
My project for this internship is beam development. So here at the CAMS facility, I'm working on learning about the ion source, learning how to actually tune the beam, how to get our beam to increase, how to change its energy, how to move it around, how to actually see it in the end and actually be able to do experiments with that. The beam is really important to this project because being able to actually manipulate the beam helps us control how much beam we're getting on target. This is significant to the fact that having too much beam might over-irradiate our target to what we actually want. So this is a way of maintaining a controlled environment within our beam.
So at CAMS, before you do any sort of irradiation or any experiment, you have to actually theoretically calculate how much you're going to produce. And so I do that. So I'll look at, okay, how much are we expecting to produce? And is this between, are we under what we need to be? And so if it isn't, I'll say, okay, well, we need to change something in our experiment so that we are actually under the limit and be safe about it. So I'll have to look at things like the beam intensity and the time irradiated and the thickness of the target and the density and things like that.
My part of the project has been working on the detector efficiency calculations and the calibration of the detector. So after we get the target or the sample irradiated, we have to now detect what exactly is happening with that sample. So they will emit different rays. We're using a germanium detector, which will mainly be capturing gamma rays.
One of my favorite experiences being here at the lab has definitely been interacting with everyone, because everyone has such interesting thoughts and ideas, and they're all working on very cool things. And I love just getting to learn more about what they're doing here, how they got here, their path. And to me, that's really important because as a woman in STEM, just feeling like my story is heard, and that I'm not alone in my path to become a scientist.
And the goal is, because a lot of undergraduate students don't have access to dedicated nuclear chemistry or nuclear physics classes, to introduce them to the concepts that they would need when they come to do their internship here. And another important goal for that was to help the students build their own scientific identity.
My role in this program is to provide a science education lens to the program to kind of evaluate the efficacy of the program, as well as identify students' experiences, how certain program components shape their science identity and shape their sense of science self-efficacy. Some students came in with the idea that to be a nuclear scientist is to be white, to be older, and to be male. And so by being exposed to mentors and laboratory scientists that varied in their demographics, that also contributed to a shift in, maybe a nuclear scientist is me. I am a nuclear scientist. Anyone can be a nuclear scientist.